guys, I'm Pico, and today we're going to create a super fun function inspired by fractals. Fractals are geometric shapes that keep repeating at various scales, and today we're going to make a fractal tree. It's gonna be easy and fun. Let's get started. So the first thing we want to do is create a new folder, and let's call it Fractal Tree Fun. And then we want to open this folder in Visual Studio Code. Now let's create an HTML file and add in the boilerplate. Now let's change our page's title. Let's call it Fractal Tree Fun. Now let's create an index.js file to keep our JavaScript code, and let's use the script tag to link it. Alright, now let's go to our index.js file. In order to create a visual representation of the tree, we're going to use SVG, or scalable vector graphic. Let's create a function that would draw the SVG for us and append it on our page. Let's call it drawSVG. So const SVG equals document.createElement NS. NS stands for namespace, and we want to add in the namespace for SVG, and then we want to specify that what we're creating is an SVG element. And now let's set the width and the height of our SVG. Let's begin by making it as big as our window. So window.innerWidth. Of course, we can change that later. And also the height. Let's also make it as big as our window for now. Window.innerHeight. And now let's append the SVG element to our document's body. Now let's call our function. Let's see if we can see our SVG element on our page. So in order to be able to see our SVG element, just to make sure that our code is working correctly, let's change its background color. We want to make it light blue. And now to draw our fractal tree, we're going to create another function. Let's call it drawFractalTree. Now, in order to be able to dynamically play around with our function later, we're going to pass in a bunch of variables as params, like for example, the x and y. The x and y coordinates here present where our starting point of our tree will be, so basically the location of our tree. And then we want to also add in length as a param, which represents the length of the first line that we're going to draw, which is the trunk, and this will allow us to control the size of our tree later on. We also want to pass in depth. So depth here represents the number of recursions, or the number of layers our tree will have. We would also like to be able to pass in the branch angle as a param, which will allow us to control the angles between branches later on. And we also want to pass in the SVG element as a parameter as well. drawFractalTree is going to be a recursive function. A recursive function is basically a function that keeps calling itself. Recursive functions need a base case check to prevent the function from infinitely calling itself. And our base case check is going to be if depth is 0. When we reach 0 depth, we want our function to stop, therefore return. Alright, and now let's start drawing our tree. We're going to be using the line element, which is a basic SVG shape used to create a line connecting 2 points. So let's start creating our line element, document.createElement NS. And just like we've done with our SVG element, we're going to also pass in the namespace, and this time we'll specify that we're drawing a line. The line element requires 2 points, so it needs an x1 and an x2, a y1 and a y2. Our x1 is the x that we're going to be passing in. So line.setAttribute x1 is x, and likewise the y1 coordinate is going to be the y param that we'll be passing in. All right, so now we need to calculate points x2 and y2. So x2 will be representing the horizontal displacement of our point. Y2 will be representing the vertical displacement of our points. And in order to be able to calculate them, we're gonna need an angle, an initial angle. Okay, so let's declare a variable with our angle. This angle, this particular angle, is going to represent the orientation of the first branch of our tree, or rather our tree trunk. And we want our tree trunk to be facing upwards. So we want to give it an angle of 90 degrees. The equivalent of 90 degrees in radians is pi over 2. Therefore, our angle should be math.pi over 2. However, if we keep it positive, then it will be drawn pointing downwards and we won't see it. So we need to add a negative sign. So now that we have our angle, we will be able to calculate x2 and y2. Let's start with x2. So we want to add to the initial x coordinate, since the value of x2 will be basically the end point of the line that we're drawing. So we'll start with the initial point, and then we'll add that to the length that we're gonna pass in. And now we wanna multiply that by the cosine of the angle. So the cosine of the angle would give us a numeric value that represents the ratio of the length of the adjacent side to the length of the hypotenuse in the right-angled triangle. Now let's calculate y2. And just like we've done when calculating x2, we will start with the initial coordinate, so y, and then we'll add it to the length times math dot sine angle. So sine angle would give us the length of the opposite side over the length of the hypotenuse, which means that when we multiply it by the length, which in our case equates to the hypotenuse, then we're going to get the length of the opposite side. Okay, now it's time to add the x2 and y2 coordinates to our line. So line.set attribute x2, and we're passing in the x2 variable, and we'll do the same thing for y2. Okay, and now our line element is ready, so we can append it to our SVG element. So SVG dot append child, I want to append the line. Since our goal here is to create a tree-like structure which starts with a single line, and each line just branches out into 2 lines recursively. So we are going to recursively draw 2 lines, and we're going to accomplish that by calling our function, the drawFractalTree function, twice within itself. And this way it will just keep going until the depth equals 0, since this is our base check. All right, let's do this. So we're just gonna call the function. Since we want the upcoming branch to be drawn at the end point of the line that it follows, we are going to pass in x2 and y2 as the initial coordinates. Okay, the next param we need to pass in is the length param. And since we want each line to be shorter than the line it follows, we are going to multiply the length by, let's say, this time we can try 0.7, and that would make it 70% of the length of the current branch. The depth param should represent how many levels of recursion are left, we want to take away 1 with every recursion. Now it's time to add in the branch angle param. The branch angle should ideally help us control the orientation of each line as well as the angle between the branches. To do that, we're gonna need to alter our code a bit. So earlier we have defined a variable which is const angle. However, since we only want the trunk to be 90 degrees, then it would be better if we comment out this line and instead add the initial angle as a param. And let's change the code a bit. So our x2 would be x plus length times math, the cosine of the initial angle instead of the angle. And now let's pass in the value for our initial angle. And here we want it to be the angle minus the branch angle. And now let's add branch angle as a param also, and SVG. Okay, so this is the first recursion, and let's create a second one so that each branch would spawn 2 more branches. Okay, so drawFractalTree. The x and y coordinates would be the same, so we'll pass in x2 and y2. Same for the length and the depth. It will also be depth minus 1. The angle that we're going to pass in here, however, for the initial angle parameter is going to be different since we want our branches to spawn in a different direction, in opposite direction. So we'll make it initial angle plus branch angle. And we're also going to be passing in the branch angle as a param and the SVG element. Okay, so now it's time to call our drawFractalTree function and actually see it in action. Let's go to our drawSVG function and add in a call for our drawFractalTree. Let's put it above the line where we append the SVG. All right, so drawFractalTree. Now let's add the params. We want our function to be in the middle of the page. So let's add in the x param as window dot inner width over 2. So let's add the y param as a window dot inner height. Okay, now the length. Here, the length represents how long the trunk of our tree is, the first branch. Let's make it 200 for now. Next, we need to add the depth, how many recursions we'll have or how many layers. Let's make it 8 for a start. Right, and now the initial angle. The initial angle we've talked about earlier should be negative math.pi over 2. And the branch angle, let's start it to be math.pi over 6, which should equate to 30 degrees, I think. Okay, and finally, let's pass in our SVG element. Okay, let's check on our function and see if it actually works. Okay, it doesn't. We can't see our tree, which is not great. Okay, let's try to debug and find out why that is. Okay, so let's first make sure that we added in all the params correctly. Seems like we have. Okay, maybe we could try giving our line a stroke, like, you know. So let's try that. So line.set attribute stroke, and how about we make it brown for now? And it worked. Yay, we did it. Okay, so now we have a fractal tree, and there are so many fun things we can do with it. All right, let's make it look more like a tree by making the first few branches brown and the rest green. That could be cool. Okay, so we're going to get back to the line where we set the stroke attribute, and we will add in a conditional. So if depth is greater than 5, we want the color of our stroke to be brown, else we want it to be green. And it worked. Cool. Okay, excellent. How about we also make another adjustment that would make our tree look cooler and more like a real tree. Let's try to make it so that the trunk, the bottom of our tree, is thicker than all the other branches, and each branch is a bit thinner than the branch before it. So to do that, let's add in the stroke thickness or the stroke width as a param, and then let's define our stroke width as a const. All right, and then we want to set the stroke width as an attribute. So line dot set attribute stroke width, and then we want the stroke width to be equivalent to the stroke width that will be passed in. Okay, and then we want to define another we want to declare another variable, and let's call it child stroke width, and let's multiply the stroke width by 0.8, and this way every coming stroke or every coming branch would be 80% as thick as the branch before it. Okay, and now in our functions here, let's add in the child stroke width as the param. All right, and here where we call our function, let's add in a stroke width of, let's say, 8. Okay, and there it is, and it gets thinner with every branch. It worked. Cool. Okay, another thing we could do that could be fun is try to see what happens if we create a tree with randomized branch angles. So over here where we pass in the branch angle, we could, instead of dividing it by 6, we could divide it by a random number within a range. So math.random times, let's make the range between, let's say, 8 and 2. So 8 minus 2 plus 2. This way we'll get a random number between 8 and 2. Okay, let's see. Yep, we get random trees. Cool. How about we do something else and we give each branch a random color? To do that, we could just create a function that creates random RGB colors. So let's call it random color gen. So const r would be math.floor math.random times 256, because we want a random number between 0 and 255. Okay, and then we're gonna do the same for the G and the B. So I'll just copy the R, copy this and just change. All right, and then we will return the RGB color as a string. So RGB, and then we want to open a bracket, and we'll pass in the value of R, comma, the value of G, and the value of B. Okay, let's try out our function. So let's go to where we're setting the color of our stroke, and let's copy this line and then comment it out. And let's paste it, and let's change this part where we're setting the color of our stroke, and just call our function instead. And now let's refresh, and yay, there it is. How about we make the background black, because I think it would look cooler. I think, yeah, it looks cool. Cool. Right, and we can of course play with the values. Like for example, let's see what happens if we make the range between 2 and 5. Okay, nice. What if we make it between 3 and 1? Oh, that looks cool. All right, guys, I guess we've done it. If you have any questions, please leave them down below, and I'm going to get to answering them as soon as I can. If you liked the video, hit the like button. If you want to see more videos like that, hit the subscribe button. Oh, and I'm also going to leave links to the GitHub repo, and maybe I'll make a code pen. I'm not sure yet. We'll see. If I do, I'll leave it in the description as well. Yeah, that's it. So have a lovely day, and see you next time. Bye-bye.